Hi all, wherever you are. Thank you so much for joining my module, Advanced Quantum Theory. What I'm going to do now is like lecture 0, because I'm going to provide you a bit more detailed information on what to expect. So let's have a look. If you need to contact me for any reason, I am Professor Carla Faria at UCL. Although I'm not there, I'm working from home as everybody else with this pandemic. So just drop me an email and I'll see what I can do to help you out. Now we're going to start with our course overview and with a brief outline. So first of all, I'm going to provide some information for new students who are just joining our program. Then I'm going to discuss how our course is structured. I'll talk about assessment. I'll mention prerequisites, so what you really have enabled to join this course, you really have to have, aims, syllabus, and the recommended literature. So let's start. First, if you are new, this course is going to take place on Moodle. Moodle is UCL's virtual learning environment, and it's really, really important that you enroll, because you're going to have web pages for each course with interactive features. You're going to have problem sheets and solutions, comprehensive lecture notes, and other course material as well. So try to join and try to have a look as soon as possible. Also, if you need to look at your grades, that's where they will be for your problem sheets. So this is more or less how it looks. You can see below. You'll be able to log in. You have to type your password. You have to use your UCL username. If you are intercollegiate, you should have been enrolled. If you're not, please let me know ASAP, and I'll do my best either to enroll you manually or to direct you to the people who are going to be doing that. So we're going to have asynchronous lectures like this one. They will be as short as possible and divided by topics. I'll upload them to Moodle, but at the beginning, I'll put them also in a public platform so that everyone can have a look until all the enrollment has been settled. I'm going to use Zoom, PowerPoint, and I'm going to perform also more detailed computations in an iPad, because we're going to have a lot of technical things in this course and we need to discuss that. Any questions that you may have can be sorted in synchronous lectures. What I'm going to do is I'm going to have a Q&A based section once a week. This is going to be a 1.5 hour section. There will be a Moodle forum for each topic. I really would appreciate if you could post there, because I think it's useful for everybody for revising, discussing, etc., etc. Also, please post your questions on Moodle 1 week in advance, if you can. A few days is fine, and I'm happy also to deal with questions on the fly. But the main point of this is that I can copy and paste the questions and organize and bring them to the next Q&A session, which I think is useful for everyone. So if we talk now about assessment, your main mark is going to come from your exam. This is going to be online. It's going to take place over 24 hours. It's open book, and it's going to happen in the 3rd term, which is the summer term. 10% of your mark is going to come from the problem sheets. Do make an effort to hand them on time. You'll also be able to upload them via Moodle, and there are formulas for being late. Obviously, if you are a few hours late, I'm not gonna care, because I think it's crazy with all these time zones, but UCL has very rigorous policies, so do make an effort to upload these in times. And here you can see how your mark will be reduced in case you are late. Please note as well that some people have reasonable adjustments, and I'll have a list of them prior to the course. If you have a reasonable adjustment or are in this category, let me know as soon as possible, because this is typically up to 1 week after the deadline of the problem sheets. And after that week, I'm going to upload the solution, then I cannot be able to accept anything. But if you are a SORA, drop me an email and say, Carla, I'm a SORA. Just to make you aware, I'll have a 1 week extension on top of the official deadline. And I would really appreciate that. Now, what do you need to do to attend and perform well in this lecture? Well, you're expected to have attended and passed quantum physics or quantum mechanics at UCL or equivalent. If you are in doubt, do have a look at the syllabuses. You'll be able to find them online. And below you'll find a bit more detail about the topics that should have been covered. States, operators, and time-independent Schrödinger equation, Born probability rule, transmission and reflection coefficients, Dirac notation, harmonic oscillator, energy eigenvalues, ladder operators, time-independent perturbation theory, at least in non-degenerate case, and applications to atomic physics. And what we intend to do in this course is to review and extend the basics of quantum mechanics in more formal mathematical terms. We also would like to explore the WKB approximation, which is very important if you're dealing with tunneling and transmission for potentials of arbitrary shapes. So in this sense, we're going to go beyond what you typically see in your undergraduate course, where we deal with exactly solvable models. Also, we aim at describing light in quantum mechanics and use James Cunningham model to describe atom-light interactions. And this is very important if you are someone who is going to work on optics. You need that badly, badly, badly. And we're also going to explore advanced topics in dynamics of quantum systems, such as time-dependent perturbation theory and open quantum systems. And these techniques that you're going to learn here and the terminology, they are going to be helpful for specialist courses that you are going to take in your master's, and also research projects. In fact, many of the things you see here are the bread and butter, and our aim here is to give you a good background so that you can build up on that. So let's start discussing the course syllabus. First, we're going to start with a big overview to put everybody on the same page. Now, this is going to take approximately 3 weeks. Online, as I said, we're going to have some chunks that I'll upload. And here we're going to talk about abstract vector space, norm, inner product, basis, linear functions, operators, column vectors, etc., etc. So you can see that many of you have seen this in your undergraduate course, many of you would not have. But what is going to be different is that we're going to be a bit more formal than what you're used to. And this is important at the career stage you are at right now. So we're going to talk about entanglement, compound systems, statistical states and preparation, density operator, etc., etc. You can read here the whole list. After that, we're going to spend 2 weeks discussing the WKB approximation. And in the WKB approximation, we're going to make an ansatz, and you see that this is nice for potentials of arbitrary shapes, but they have to be smooth. And then the question is, what is smooth? And when do they fail? Because this is an approximation. At some point, this is going to fail. And you need to know in what regions they're going to fail. And you need to know to connect, for instance, what is happening in one region and in the other region. So this is going to be important. Also, we're going to talk about unitary evolution. So we're going to see many things that you use in several areas, such as mine, which is strong feeling not a second sign. So you will see Heisenberg picture, Schrödinger picture, interaction picture, how you switch from one picture to the other, unitary evolution, two-level atom, dipole approximation, rotating wave approximation, etc., etc. James Cummings model, as we mentioned before. And after that, we're going to talk about time-dependent perturbation theory, which is hugely important for many areas of physics. For instance, quantum optics, quantum information, I mean, you name it. And we're going also to consider some applications and also talk about Fermi's golden rule. And finally, we're discussing open quantum systems at the end of the course. And open quantum systems are very important if you are dealing with big systems. For instance, biological systems, for instance, nanostructures, for instance, how do you treat a system with many degrees of freedom quantum mechanically? Well, it's tricky, right? Because you need to see what degrees of freedom are important and what are not. So what is not important, you're going to write as a bath. And what is important, you have to treat in more detail, and you have to see what is the environment, how a system will interact with its environment. How is this all going to develop? And this is going to be very interesting for many areas. People use this a lot as well on solid state physics. And every time you have a big system, you really need it. So this is the syllabus. Please note that the number of hours or also the number of weeks allocated to each topic is tentative, especially under the present context. And I will try my best to stick to what I have given you here, but obviously this will vary during the delivery of the course. We're going to cover the whole syllabus, but these hours and these weeks, there are more guidelines than what is going to happen in reality, if you know what I mean. So we have our own lecture notes for this course. They're also going to be updated during the term with regard to accessibility, context, etc., etc. But it's always nice to have a look at those textbooks. They are recommended textbooks. So, for instance, Quantum Mechanics, Brandon and Joachim is quite complete and quite nice if you want to go in the optics direction. Quantum Mechanics by Cointanucci, Gill, and Laloe is like the Bible. It has a lot of information, a lot of complements, and this is a book I bought in my undergraduate course and I still use nowadays. So it is excellent. Modern Quantum Mechanics by Sakurai is also great. And Quantum Mechanics, Marsbacher is also quite good, especially for unitary transformations and scattering and similar things. So please note, this list is non-exhaustive. I may add other books or even science articles as suggestions. There are also lecture notes, as I mentioned at the beginning. But it's always important to start from somewhere and to have a nice guideline. Office hours. Well, let's try to use the synchronous plenary Q&A Zoom sessions for discussions as much as possible, because online and with pre-recorded material, this is unfortunately something that will be missing. I asked for a slot in the early afternoon London time so that I can accommodate everybody. It's like early evening in Asia, but people from America can still join, etc., etc. But I know sometimes this is also not viable or something may happen. So in case you need to discuss with me on a one-to-one basis, please let me know, but allow at least 1 week notice and I can see how I can fit you in. But I would really ask you, let's try to stick to the synchronous sessions. And please note as well that the plenary sessions are on Zoom. They're going to be recorded. So I'm going to put this big everywhere on the Moodle page so that everybody knows. But if you feel uncomfortable with that, you can switch off your camera or microphone. But it's an important point because we're not going to have on-site questions. So it's the best way to help everybody. Okay, so that was my lecture 0. And I hope you enjoy this module, and I would really like to thank you for your attention.